Great, I think we'll make a start there. So thanks everyone for joining us today. You can see people from sort of different regions in Europe, so welcome to everyone wherever you may be. My name is Adam Self and I'm the Supply Marketing Manager at Distrelec. I've been with the company for 3 years now. Today's webinar is going to be delivered by Peter and Volker from Phoenix Contact. They have 20 years of experience between them, so please ask them anything. If you do have any questions, please use the Q&A function at the bottom and we will answer as many as we can at the end. Before I hand over to Peter and Volker, I just want to remind everyone that the webinar will be recorded so we can use it for future marketing purposes. So over to you guys.
Okay. All right. Thank you and a warm welcome also from my side. Thank you, Adam, for the introduction. So we like to present today the Power Reliability webinar with the topic Transparency from Load to Mains. My name is Volker Bramm and I'm here with Peter Ketler. So I hope you can see all our screen. So Adam, can you see the screen?
Yep, all good.
Perfect. So we will start then. All right, this was a short introduction to our webinar. So as you may see already in the presentation, in the video, that we today present the communicative 24-volt system. This is the system which enables you to have high power reliability and to get transparency from load to mains. There are three components in the system. In the front, you see the power supply. This power supply provides the energy. On the left side, we see the electronic circuit breaker system, Kappa Rock, which secures the 24 volts. And on the right side, we see our DC UPS system in combination with the battery. And these can be combined with each other in order to get this full transparency. So let's have a look on the agenda. So we will have a short introduction on Phoenix Contact, somebody who may not know Phoenix Contact already. Then we will show the components of the communicative 24-volt system you saw on the slide before. And the third point will be the system and the demonstration, what you can do with it. Okay, so Adam already said something to us both here. So Peter Ketler is my colleague on the right side. He's a product manager for circuit breaker. And I'm Volker Bramm. I'm the product manager for power supply, especially Quint product family. And combined, we have 20 years of experience in power supplies and in electronic circuit breakers.
Here we can see an overview of the company headquarters of Phoenix and the competence centers. It is located in Germany in a small town named Blomberg. You can see many buildings, and we have a big growth up the last years, and also we are built up every year some new buildings. When we view around the world who is Phoenix Contact, we have 11 production sites with more than 20,000 employees worldwide and more than 10,000 in Germany. We are founded in 1923, and that means next year we have the anniversary, is 100 years anniversary, and today we are presented in more than 100 countries. That means we have more than 100 innovative products to get your solution and to give different functions in the switching cabinet.
All right. So where you have to locate our products and where we are talking about. So when you have the cabinet, Phoenix Contact is providing a lot of components in the cabinet. We separate these topics in different headlines. So today we are talking about power reliability. So providing the 24 volts inside of the cabinet. to have this secured and also be transparent for everyone in order to have the full idea what's going on there. So when you take a closer look on power reliability, then you see it's also organized in different topics. So when you go from left to right, you see the topic protection. This is done by our surge protection components. Then we have a monitoring capabilities to monitor our energy flow. Afterwards, we have the supply, which are the power supplies and the OPS systems. And then we have the topic of secure. This is the electronic circuit breaker systems. And lately, and at last, we distribute this energy. And you know, Phoenix Contact is famous for terminal blocks, and we have a wide portfolio here in order to support your application. Today, we will talk more about the supply and secure. So this would be our focus. So now you know where we are located with this topic. I just want to give you a small information about the portfolio we have in power supplies. So small information how you can get there. You go to phoenixcontact.com, and when you are there, you can go on products. Then you found power supplies here as a section. Click on power supplies. Then scroll down to the bottom of the page, and there you find this green button. And this green button enables you to open the e-paper we have. So here you see our brochure. It's an electronic brochure where you see all the portfolio from power supplies. So we are the company with the widest portfolio in the market for DIN power supplies. And just to give you an idea how you can organize it. So basically we have 4 different functional types of products. On the left side, you see the power supplies. This power supplies provide the energy. Then we have DC converters of different voltages, and also DC-AC inverters to manage your DC current flow. And the third component is a redundancy module. So we have a full portfolio of redundancy modules, which enables you redundancy and monitor redundancy. And last but not least, we have the uninterruptible power supply. This comes in combination with a battery typically. And this are products which are available for DC currents and also AC currents. All right, so today we will talk about the different product families. So we will talk today about Quint Power, which is a product family with the highest capabilities and reliability. Furthermore, we have also product families like Trio Power, Uno Power, which provides a more standard or basic functionality when you need to be more cost effective in your application. Okay, so now let's have a look on the Quint Power, which is the main actor in this webinar. So let me have a look here. So this is our power supply from Phoenix Contact. It's a power supply for 3-phase, 24 volts output and 20 amp. We also have a variant for 40 amp. You will later see in our demo cabinet. So you see on the lower side, the terminal block is the input side of the 3 phases, 400 volt, 480 volt AC. And on the upper side, you see the output, 24 volts, 20 amps. And of course, this power supply has the functionality of Quint Power. So it has a very robust input, has a powerful output with boost and overcurrent capabilities. And as well, the focus on this power supply, which has the suffix IOL, is the signaling. So let's have a smaller, more detailed look on the signaling terminal block. So when you go from above to low, you see we have a 1314 dry contact. So this is for standard monitoring. So everybody uses this in his cabinets, I guess. So you can use it as well in your application. The poles below are for the connection of IO link, so directly to an IO link master. And the lower two poles are for the system bus in order to interconnect this device to another Phoenix component. And below you see as well, we have an instant idea what the power supply provides as energy level. So you see the output power and also the DC OK. So at first glance, you have an idea if everything is working fine. All right. So then we have here a small selection of data you can get out of the power supply. So there's a lot more, but here in selection. So we can detect the current output voltage. We provide the output current you have in the current moment. The input voltage on each phases are provided. The temperature in Celsius is monitored, can be monitored. We have a lifetime monitoring, which we will explain in a few seconds. And as well, we have a digital nameplate in order to identify the product, to reorder it, to know what's the hardware status and when it will be produced. And the last point here is the phase failure, of course. This is a very helpful function that you know whether one of the three phases is failing, power supply runs on, but you know you have to do something about it. All right, let's have a look on the lifetime monitoring. So the lifetime monitoring contains different technical parameters. So the workload of the power supply is monitored over the time. The temperature of the power supply, which is a combination of ambient temperature as well, will monitored over the time. And the input voltage, of course, has also a relation to the lifetime. So what we get from that is a lifetime monitoring that you know when the power supply will be out or will be aged in order to be replaced. It's some kind of recommended replacement cycle time. And this helps you to profilize, to more professional organize your preventive function monitoring and maintenance. All right. So when we see the information we can get out, there's also the other way. I can also get the data in, so configure the power supply. So what we can adjust, for instance, we can adjust the output voltage. We can adjust the output curve, so the behavior of the power supply in case of an overcurrent. Should it provide all the energy? Should it switch off? And also the drive-free contact, you find 13-14 contact. This contact can be configured. So which signal you want to have there, if you want to combine some signals there, like current and temperature, for instance, and you can define the thresholds for that. All right. So these are the features for the power supply as well. You have the chance to combine it with the Kappa system. You see in a few moments with Peter's presentation, short words to that. So it provides information of the total current. It's getting in the input voltage, we get information over the over-under voltage. As a channel status of each circuit breaker is detected, so you know whether this channel is switched off, switched off to overcurrent, or it's running at normal operation. So as well, you see the constant current per each module, and of course, you will have the digital nameplate here to identify each product in each cabinet remotely. So the same topic also runs with the UPS. So the power supply communicates to the UPS as well. The difference is here, the UPS has currently more a wider portfolio of field buses which you can use. So Ethernet IP, Modbus, EtherCAT or Profinet. So the UPS is a gateway for the data to get the data out of the power supply and the DC UPS. So let's have a look on the features you find on the UPS system, which will also be provided. So it's output voltage, output current, state of health, which is the battery lifetime, very important, enables you to have a good information about the upcoming remaining lifetime. So it also enables you to have preventive maintenance. The state of charge is also very important to know whether your current battery in the charging state can buffer your application. And as well, battery alarm is also important in order to have a push message to the PLC whether the battery has a damage and cannot work. All right, so these are the options you have for the power supply. Now we will have a look on the Caparock system.
Okay, here you can see is a whole Caparock, what is full mounted and full wired. It could be a solution for one special machine, let me say. And we can see that we have the input voltage connected on the left side with the red and blue colored wire in the bigger dimension. And on the right side, we have many, many outputs what are protected and protect some loads against overload and short circuit. And the green cable, what we can see, that is the Profinet connection to get all the data and to make some settings in the system. When we have a look to the different separate modules, we will unmount and unwire the Caparock system, and we can see the separate things what we have in the module. On the right side, first of all, and it's very important to understand, that is a current rail, and we have two bus bars in the current rail. That means we have the plus and the 0 volt integrated in the current rail, and the current rail is the backside of the system. It's mounted on the rail, and it will provide the power to every Caparock module. On the left side, we have a power module where you have to connect the power in with plus and minus, and that will be connected directly to the current rail. That means every other module what you will plug into the current rail, that is directly powered by the current rail. And in the middle, the three modules, you can see the 1, 2, and 4 channel circuit breaker. That means we have the possibility to build it up however you want it for your application. And also you have 4 connection points per module. That means you have also integrates the power distribution in the module, and you can connect directly up to 4 circuits per channel. And the module with the blue pusher on the right side, that is a 0 volt potential distributor. That means you can also integrate it in the system to every circuit breaker if you want that. And you have the plus and the minus next to each other to connect the load directly. Then also we have an online configurator. You will also find it on our webpage. You can use it to see how looks the system, what you want for your application. You can build up your own system via drag and drop with the mouse. It's very easy to see what you get when you build up the system there. And later on, you also get all the digital data like the marking, the system data sheet, the 3D data, and so on. That means you have a big digital package where you get the information to that system, what you have configured before. On the left side, we see the solution ID. When you use that solution ID to the searching bar on the top of our webpage, you get that system later on at any time. That's very easy to find your own solution. But also you can send it directly to your email to find it later on easier. That means you have one special number what describes that system, what you have configured also with the marking and so on. Here we can see that the modules be also able to pull out via operations. That means all the modules what are connected in parallel, they are still powered and not interrupted. And you can also plug in other modules and you can expand the system later on very easy. When we have a view to the wires, you can connect the plus to the orange pusher module, to the circuit breaker, or the blue wire to the blue pusher minus distribution. That means you have the connection for the load directly in front of the Caparock system. Here we can see an overview of the different LEDs. We have green LEDs, what means the channel is switched on and everything is fine, it works. If we have a yellow or orange LED, it will show that maybe there could be something trip because it's a pre-warning. That means 80% of the channel is reached, and maybe you have to look what has happened in the machine. If we have a look to the right yellow LED, we get a failure, it will trip, and we have a red LED to show something is wrong in the machine, and you get an information to your PLC via Profinet in that case. After repair the machine or the device to change it, you can switch on the channel again by pushing the LED button. That means it's not only an LED, every LED is also a button, and you can switch on and off every channel, and you can make the setting also in front of it. Also, it's possible to do it remote via Profinet to switch on and switch off the channels how you like that, and also you can make the setting for it. Okay, that's it from the video from the Caprock system. Now the next part is that we will show it at the hardware, the different systems, to understand how you have to connect that and how you can use it in practice.
All right. So here you see our hardware setup. So you can see basically the wiring. In this case, we have a power supply, UPS system, and a battery. So first, the power lines. So we see below, we see the 3 phases coming into the power supply, converting to 24 volts 20 amp inside the DC UPS. Here, the UPS decide whether getting the energy from the power supply to the load, or in the case of a mains failure, the power will coming out of the battery connected here. So this is the power lanes. So of course, we're talking about communication and information. So we have a data connection here as well. So here you see the system bus connected in white and gray. So this will be connected here to the UPS. And this data wire will also go to the battery. So we have a full data transmission from each component. And then here below, you have 2 ports for the field bus in order to provide the data from the UPS as central gateway. All right. So of course, we also can have a look on the Caprock as well. It looks quite similar. So here you see a small mock-up. So in this case, the power supply is also here provided 3 phases, 20 amp going out there and 24 volts. It will be delivered here down in the head station, here where also the Ethernet cable is attached. And as Peter explained, this is now transmission to each circuit breaker module. And in order to establish a data connection, these 2 wires are connected down here to the terminal block. This wire are standard wires on both setups, so you don't need a special wire to connect to establish a data connection. Then on the front, we have 2 Ethernet ports you can use for daisy chaining your Ethernet system in order to get the data from the PLC. All right, so now let's have a look on the Caprock system Peter will provide.
Okay, let's have a look to the different accessories of the Caprock system. I explained to you the different current rails, but in detail, I think it's good to understand that there are different modules in this Caprock system. That means we have initial current rails without metal parts on the sides, and we have extension current rails where you get directly the connection to the next current rail, and you can push it together on the rail, and you can mount up the system how you want it for your solution. That means you are able to expand the system very easy also with the current rails, to mount it later on, to expand it later on, makes it very easy. Okay, let's have a look to the different modules. We also showed to you in many slides that we have a Profinet power module where we have also the plus and the minus connection. We have the connection to the twin power, and we have the connection to the current rail. I will plug it into the current rail first without a tool. You also can pull out without a tool. But in addition to that, we have two different additional power modules. First of all, we have the status reset module where you get a status output if everything works fine in the system. We have a reset input for remote reset, and we have for 80% pre-warning. In addition to that, we have the possibility to connect also the IO-Link connection to get the data not via Profinet, to get it via IO-Link. We have also the possibility with a second interface. Then we have the different circuit breaker. You can see it here as hardware in front. That means we have a 6mm one-channel circuit breaker with the connection points. And to mount it, you have to push it together and shift it to the current rail, and it's directly powered by the current rail. Then we have the two-channel circuit breaker where you can make the setting with the screwdriver, push on and off the different channels, and also again slide it into the current rail. And when we have a view to the four-channel circuit breaker, we have 12mm for 4 channels. So that means only 3mm per channel. That's a very slim sized product and 1 connection point per channel. And also we can push it in. And last but not least, I have the minus distribution again. And you can see that the colors are blue because it's easier to see what is the potential of that connection point. If you use that at the circuit breaker, you have directly the protected plus and the minus next to each other. You can directly connect the load with plus and minus. Makes it much easier for wiring and for searching some failure in the machine, let me say. Let's have a look to the application. I will go over to the switching cabinet and show you the hardware. Okay, here we have prepared a switching cabinet with some different components. We can also adjust current and make some phase failure to show you what will happen. That means, first of all, here we have 2 different applications, what Volker also explained. That means we have here, first of all, the power supply, the UPS with the battery, everything is connected with the data. That means you get the data for the different modules, and you have a rough overview about the different settings, what you also can set up different values. Here we have the CAPROC system, the electronic fuse system with the twin power connected also with the data, what Volker explained. And we have the Profinet connected, it's directly connected to our PLC, so PLC Next. And here we get the data out. And here we have a visualization integrated on the PLC. And that visualization we like to share with you to explain you how it works.
All right, now you should see my visualization. So this is an example of visualization which we did for this project. So it's a selection of data you can get out of the system. So you see here we have the data from the power supply getting in. Like voltage, output voltage, which can be added, and also the output current. Also, the 3 conditions here are monitored, like DC OK, phase failure, and temperature warning. On the right side, we see the features and the data from the CAPROC module, a small selection. And here on this side, we see the different channels. So we attached 4 channels here in total, so 2 times 2 channel modules. And what you here see is we adjusted 4 amps to this channel, and this channel is already at the border, so to say. So it's really like you have here almost the threshold for the tripping reached. And what we now can do is to edit, for instance, the channel in order to have a new threshold, to don't have that kind of tripping here problems. This can be directly done. So what Peter now done in the application, you may heard the clicking sound, is the phase failure detection. So you see below here we have the phase failure, which is detected, and with that, you see that the power supply immediately communicates that one phase is fading, and this can be forwarded to the PLC. All right. So let's have a look on the circuit scheme again. All right. So now you should see the Phoenix Contact slogan here, and now we take a small look on the circuit schemes. So just to give an pretty simple overview of the circuit diagram we have here. So here you see the power supply below. Above you have the system bus connecting the electronic circuit breaker, and from that we going into field bus, in this case Profinet. This will be provided to the PLC, and later the PLC can provide the data to upstream computer or HMI or another PLC. In case of the solution with the battery and UPS system, you see we have this kind of option. The power supply is connected to the UPS, and the UPS provides the data to the upstream PLC. In Profinet, Ethernet IP, EtherCAT or Modbus. Furthermore, it's not only about field buses. We also have a solution on IO Link, and this is a solution which you find more attractive, as you already have an IO Link master in your application. And some free ports on this IO Link master, and then you can directly integrate the power supply via the IO Link connection to the IO Link master. And also, as Peter explained, we have a Caparock module with IO Link. You can also directly connect it together. And then in case of the UPS, it's done at a quite different way. So in this we see that the power supply itself is using itself as a gateway for the UPS and the battery. So it's collecting all the data and provides the information to the IO Link master. And of course, you know, IO Link masters can be attached to the PLC. In the case of our demo cabinet, it was directly attached to the PLC, but there can also be a separate IO Link master with bus coupler, which is then separately located and then connected to the PLC. So these are the ways. So now you have an idea about the components you have, the different capabilities, how you interconnect them. I think fitting for your system. So now we have a look on the general functionality, what this system can provide to you. So what kind of option we have here? So basically, we can do energy monitoring. So we are able to monitor the energy from the mains to the load, back and forth. You know which each channel is consuming as energy, can monitor it all the time in order to find out whether something is going wrong. You have the device identification, so you always are aware what kind of components are used in your system for follow-up in order to find out which components you have in the systems all over the world when you sell your machinery somewhere. And of course, you have the condition monitoring. So you are fully aware of all the conditions like temperature, voltage, current, or also lifetime. And also, as I explained, you can configure the power supply via PLC. So you centralize all the configuration and you reduce your failures you will have in your system, as you will do it automatically. Also, you have the capability to reduce failures on remote applications, like on ships or any application where you are not fully aware or convinced that there's somebody who is able to configure the power supply in the way you like it to. Then just plug it to the PLC, and then this power supply will be automatically configured, as well as the circuit breaker. All right, I just want to give you some inspiration, what you can do with that, basically. So some practical inspiration for you. So let's have a look on example use cases, which you may find interesting. So one thing is maybe a cabinet fan. So a lot of cabinets in warmer countries are cooled by a fan, and this fan is also important for the application, for the reliable operation of the application, and it should work. When this cabinet fan is so polluted or it's dirty, it is less effective. Another effect of that is that the currents will rise, so the in the cabinet fan, and you can monitor that kind of current over the time in order to make preventive function monitoring for that fan. In case you need an input voltage monitoring in your application, but your customer may not want to pay extra for it, or he has no space in his cabinet for that, our power supply is able to provide data above the input mains, one phase failing, about the voltage of each mains, about the frequency of the direction of rotation. All this information is available for you. You can get it from the power supply. A third thing would be the preventive maintenance. So you have a business model that you have to maintain the application of your customer, or you want to reduce costs in your own application, then we really recommend it to you to use products with lifetime monitoring, like the Quint Power system in Caparock and the Quint IQ. So here you can know what the remaining battery lifetime is, and also unique on this Quint 4 IOL device we showed to you in 20 and 40 amp, they also are capable of monitoring their lifetime. And you don't replace the power supplies and the battery too early. You always have the right time, and you don't do it too late, that you lose your power reliability.
Okay, where you can find all that different data. First of all, at our webpage, you will find everything to the true power reliability and all the content what we have seen today. That means, for example, we have a user manual for the Caparock system and also for the Quint Power and the other parts. We have some tools to make some visualizations. And also we have, for example, an automation engineering tool. That name is PLC Next Engineer, to build up the products and connect them with the Profinet and so on, to build up the complete application, and to make also the setup of the different things in the application. And also you will find on the webpage the different files to configure the Profinet modules, Ethernet IP and the others, also IO links. That means we have for all the different components, we have the files what you need to integrate it in your system. Also we have functional blocks, and you will find everything on the webpage of Phoenix.
All right, where you can order the components of the communicative 24-volt system. So first, to separate the different types of components you can use for that system, we first start with the power supply. So we have two versions here in three-phase, 24-volt DC, 40 amp, 20 amp IOL. So you can order them on the Distrelec webpage under this article numbers. Then the next point is the Quint DC UPS. This Quint DC UPS is here mentioned in the Profinet variant in 5, 10, 20, and 40 amp version, 24 volts DC. And this is an selection of our portfolio. We also have the same power classes in the other field buses, such as Ethernet IP, EtherCAT, and also Modbus. Then we have the Caparock power modules, which are the head modules available with standard signalization, SR, and with Profinet. as well as IO-Link. The number for IO-Link will be released soon on the Distrelec page. And as well, you have the circuit breaker modules, which shows you the which enables you to protect the separate channels in 1-channel modules, 2-channel, and 4-channel modules. Also here with the Distrelec number. And last but not least, you have the 0-volt potential distributor. This is also not already released, but I think it will be available on the Distrelec web page in a few days. All right. So now we are coming to the end of our webinar. I hope you enjoyed it, and there is also chance to post some questions into the webinar in order to if you have any questions or something, or you can later send also an email to Distrelec in order to get some direct information. So when there are no questions left, then we say thank you in the first place. We like to also want to announce these results of our polls. So 91% of the visitors today, the webinar, find the power reliability as a very important topic. So I guess our system provides the information to enable you to protect that kind of power reliability. All right, then I will say thank you, and we'll give back to Adam, and also thank you to Peter. And I will like to see you in the first training then.
Yeah, thanks guys, and thanks to everyone who joined the webinar today. We have recorded it, so we'll be sending out a recording as well if anyone would like to watch it back. But yeah, if no one's got any questions, then have a great day.
Okay, thank you.
Thank you.